Hey guys, this is a quick video, hopefully a quick video on one-step and two-step equations. This is typically a 7th grade task. However, this is really applicable to all of middle school math and even for those in algebra. This is a good reminder about why we do what we do on the one-step and two-step equations. Let's get started. So, real quick, equations are equal to, they're basically algebraic expressions that are equal to a numerical expression. The big keyword here is equal. They're equal, right? So you've got one side here that's equal to the other side. Now, obviously, they both don't look like each other. However, they have the same value. So very much like if I were to say 2 plus 2 equals 4. We know that to be true. 2 plus 2 does not look like a 4, but it is equal to 4. It has the same value on both sides. If I decided to just add another 2 to the left-hand side of this problem, it's no longer equal. So I'd have to cancel that. I'd have to cross that out. However, if I added a 2 here, then we're good. It's still balanced. If I decided to take 1 away from here, well, then it's no longer balanced. I would need to take 1 away from here as well. So whatever we do to one side, we have to do the other. So in an equation, we have to maintain, the very first thing that we need to do is maintain the balance, right? Maintain the equal sign. And the second thing we need to do in order to solve for the variable, to solve for, in this situation here for number 1a, we have to isolate it. So we have to isolate the variable. We have to put it by itself. Those are the two big things that you need to do in a one-step and two-step equations. Now, one step is denoted by one step. It takes one step to solve a one-step problem or one-step equation. You've got 3 one-step equations here. The next page, we'll talk about two-step equations. You've got 4 of them here. Okay? So, what we need to do is, we need to isolate A. We need A by itself. Once we have A by itself, then we will know what it's equal to. We will know the value of A. Again, we're not looking for the answer to this problem. We have the answer. The answer is -9. That's not what we're looking for. We're not looking for the answer. We're looking for the value of A. In this situation, it's called the solution. We're looking for the solution of A. So, what we need to do, the very first step, is we have to apply the inverse operation. And what operation's taken place in this equation, or I guess in this problem that's been solved in a sense? It's adding, right? We've got an adding problem here. So we have to find out what is the inverse, what is the opposite of adding 4.9? Well, the inverse operation is subtracting, but more poignantly is subtracting 4.9. If we were to subtract 4.9 from both sides, from here and from here, not only will we isolate the variable, not only will we get this canceled out where A is by itself, we've isolated the variable, and because we subtracted 4.9 from both sides, we have maintained the equal sign. Right? Whatever we've done to one side, we have to do to the other side. So that's what we're doing here. So this cancels out. This cancels out, obviously. Right? A positive 4.9 minus a 4.9, 0. All you have left over on this side is A. And then -9 minus 4.9 is going to be -13.9. And that's going to be your solution for A. And you might wonder, well, how do I know if this is correct? Well, what you can do is, in order to check it, you can plug it back in. You can substitute this value for A, this solution for A, you can plug that back in to the equation to see if it works. So 4.9 plus negative 13.9 should equal negative 9. And it does. So we know that is correct. Okay, moving on to number 2. We want to look at the operation. The operation is minus. Okay, what specifically is happening with the R? R is being subtracted. So 17.1 is being subtracted from R. So what is the opposite? So we have to apply the inverse operation. Well, the inverse, the opposite of subtracting 17.1 is adding 17.1. So we have to add 17.1 not just to this side, but also to the other side, because we have to maintain that balance, maintain that equality, right? So what happens here is this is going to cancel out, because when you apply the inverse operation, it cancels it out here. You've isolated R. R is all by itself now. And then now we can go ahead and finish this here, this little problem, and we can come up with the solution for R. Now you can't really add those, you can't add those two. You're going to have to find the difference. The difference is close to 13, so it's going to be 12.3, I believe, yeah, 12.3. And it's going to be positive because this has more, this has a higher absolute value. It's positive, right? If we had a number line and we had 17.1 on this side of 0, and then we subtracted 4.8, we would go this way on the number line, but we wouldn't go so far to get out of the positive side to get into the negative side, right? So we'd still be in the positive, so this would be 12.3. So positive 12.3. And if you want to check it, just plug this back in. So 12.3, plug it back where R would be, minus 17.1. And the question is, does this equal negative 4.8? And you will find out, yes, it does. Okay. Moving on to number 3. Again, we're going to apply the inverse operation. The inverse operation, well, the operation right now between negative 3 and C is multiplication. So what is the opposite of multiplying by negative 3? Well, the opposite of multiplying by negative 3 is dividing by negative 3. So we're going to divide both sides by negative 3. So when we do that, this cancels out. We've effectively isolated the variable. We've maintained the equal sign because we've done whatever we've done to this side, we've done the other side, so it's still equal. Now we've got 36 divided by negative 3, and it should be negative 12. And if we want to check this, we plug this back in, so negative 3 times C. In this situation, C is negative 12. Is negative 3 times negative 12, does that equal 36? Yes, it does. So that is good. That solution is perfect. So that's a one-step equation. Now, a two-step equation, you're basically following the same set of rules or protocol, if you will. The only difference is you've got another step to take. So it's not one step, it's 2 steps. And when you apply the inverse operation here, you've got 2 things going on. You've got 2 different operations. You've got a multiplication here, right? And you've got an addition here. Now normally, when you solve problems, you follow the order of operation. You would say, please excuse my dear Aunt Sally. You would multiply first, then you would add to get the answer. Now again, we have the answer. The answer is 11. But that's not what we're looking for. We're not looking for the answer. We're looking for part of the problem, which is the solution of x. What is x equal to? So when you're trying to find out part of the problem, you're not following the order of operations. Because in PEMDAS, you follow this order of operations to solve the problem, right? But in this situation, we're going to go backwards in the order of operations in order to find part of the problem, or in this case, the solution to the problem. So normally, when we talk about applying the inverse operation, what's the opposite of multiplying by 2? Well, it's dividing by 2. But we're not going to divide by 2 yet. What is the opposite of adding 5? Well, it's subtracting 5. We're going to do that first. Normally, again, you would multiply before you add. But again, we don't know what x is. So we can't multiply, or I'm sorry, we can't divide this by 2 and be okay with it. What about the 5? The 5 is still here. So if you divide this by 2, you're going to divide everything by 2, and it's just not going to come out. So again, we're going to go backwards in the order of operations in order to find part of the problem, not solve for the answer. We've got the answer. We're just looking for x. So we're going to apply the inverse operation of adding 5. We're not going to divide by 2 yet. So we're going to subtract 5. Okay, that's going to be the inverse operation of adding 5. So we're going to subtract 5 from both sides. Not both sides here, both sides of the equal sign. Remember, we got to keep that balance. We got to keep that equality. Whatever I do to one side of the equation, I have to do to the other side of the equation. Now, once I've done that, this is canceled out. On the left-hand side, that goes away. That's canceled out. All you have left is 2x, right? This goes down. You bring that down to 2x equals, and then you got to solve this part. This canceled out, but this doesn't cancel out. 11 minus 5 is 6. Now, we can apply the inverse operation of multiplying by 2. The opposite of multiplying by 2 is dividing by 2. Sorry. The opposite of multiplying by 2 is dividing by 2. Okay, so we're going to divide both sides by 2. And instead of doing the division symbol 2, I'm just going to put a fraction bar here. And then the answer is going to be x. This is going to cancel out. I've got x left over here. And then 6 divided by 2 is 3. And if I want to check it, I simply just take the equation, 2 times x, 2 times 3, plus 5 equals 11. And is that true? Yes, I am good to go. This is the solution for x. Okay. Number 5. I've got multiplying by 3 and subtracting 1. So I want to do the opposite of subtracting 1. The inverse operation is adding 1. I want to do the opposite of multiplying by 3. I want to divide by 3. But which one do I do first? Well, again, we're trying to find the solution, not solve the problem. So we're going to go backwards in the order of operations. So we're going to add 1 to both sides. I've got what's left over. Obviously, this cancels out. I've got 3n left over on this side. And on this side, 8 plus 1 is going to be 9. Now, I apply the inverse operation of 3 times n. The opposite of multiplying by 3 is dividing by 3. So to divide both sides by 3, I'm left with, well, this cancels out, obviously. So this is n equals 9 divided by 3 is 3. And if I want to check out my answer, if I want to find out if my solution is correct or not, I'm going to throw this back in. I'm going to substitute back in. So it's going to be 3 times n, which in this case is 3. So 3 times 3 minus 1 should equal to 8. And that is true. 9 minus 1 is 8. So we are good to go. That is a good solution. Okay, moving on. 2 more. So I've got 2 times a minus 3 equals negative 5. So just to go to the y's here, don't even worry about what's on the other side. Don't even worry about this is a negative 5. It doesn't matter what this is. It only matters what's going on right now with a. What's being done to a right now is that it's being multiplied by 2 and that 3 is being taken away from it. So when we apply the inverse operation, we have to think, what is the opposite? What can I do to unravel to get rid of that 2, to get rid of that minus 3? Well, the only way to get rid of it is to apply the inverse operation. Okay? So the opposite of minus 3 is adding 3. So if I add 3, this is going to cancel out. This is going to be gone. But whatever we do one side, I have to do the other side. So the consequence of keeping that balance is that you're going to have to add 3 to the other side. Well, that's going to change things here, which is fine. Negative 5 plus 3 is negative 2. Bring down the 2a. Now, the opposite of multiplying by 2 is dividing by 2. So now we can divide both sides by 2. This cancels out. a equals negative 2 divided by 2 is negative 1. So how do I know this is correct? Plug it back in. So 2 times a, which is negative 1, minus 3, does that equal negative 5? Well, let's see. 2 times negative 1 is negative 2. Negative 2 minus 3, yes, that is negative 5. That is correct. So we are good. So this is our solution. Okay, last but not least, negative 4y plus 2 equals negative 2. Opposite, the inverse operation of both of those operations here, well, the opposite multiplied by negative 4 is divided by negative 4, and the opposite of adding 2 is subtracting 2. So we're going to subtract 2 first. Okay, we're going to go backwards in the order of operations. So we're going to subtract 2 here, subtract 2 over here. This is going to cancel out. But this one over here, when you subtract from a negative number, you actually go further deeper into the hole. You actually make the number, well, in this case, really smaller, but it looks bigger. So we're going to subtract 2 from negative 2, you get negative 4. Bring down the negative 4y here, because that's what was left over on that side. Now what's the opposite of multiplying by negative 4? Divided by negative 4. So we're going to divide both sides by negative 4. Y equals 1. We want to check it. We want to make sure we got the right answer. So we plug it back in to the equation. Let's see if that works. Does this work? Negative 4 times 1 is negative 4. Negative 4 plus 2 is negative 2, and that is correct. So this is a good solution to the equation. Hopefully that helps. I try to keep this video as short as possible. 17 minutes, not too bad. Have a great night.